Dear students, today's class we are going to discuss about statements and expressions. Okay, so this is the second experiment of your C programming lab. So here you will be learning basics of the program and we will slowly get into the experiment. Okay, so C language is a general purpose programming language. It is created by Dennis Ritchie at the Bell Laboratories in 1972. It is very popular language despite being old. Okay. C is strongly associated with the Unix operating system. So this is the structure of the C program. So here the basic structure always involves the preprocessor directives associated with the header file. So after that we will be having our main function. This is a very simple structure. So here this particular area denotes you little additional information about the structure of the C program. So in the basic structure, what we are having is preprocessor directives where we are able to include the header files. The header files are the files which consist of various predefined library functions. Then the main function. So this is the backbone of any program, any C program where the compilation process initiated here. Okay, so here we are able to see void main within bracket also we are having the void. So void main here void indicates it is an empty data type. That is any function if it is prefixed with any data type it is called as the return type of that particular function. Then within a bracket we are mentioning void. That means we don't have any parameters to get passed or any parameter we are filling there. Okay, so inside the main function, just we are printing a statement. This is an output statement. This is simple structure. Let us get into another structure where we are having the header files and also the preprocessor directives for including the header file as well as for defining some values. Okay, so the preprocessor directives are the directives of the components which are processed by the compiler at the very first. Okay, then the variable declaration. So we are able to see the location of the variable here. It is denoted as a global underscore variable is present at the outside of the main function. So it is a global variable declaration. That means any variable declared outside the main function is called as the global variable function. So here we are having a main function. So inside the main function, we are having variable declaration. We call this variable declaration as the local variable declaration, and we are doing the assignment here. Local variable is assigned to value 5. So this statement is called as the variable definition, and we are doing the computation such as variable plus value, and we have one print statement also. So here the specific component we are supposed to notice is the command lines. So this particular slash star, this is the beginning of the program, then star slash. This is a type of command line where we are able to comment multiple lines. Command lines are basically an instruction for our own understanding. In the second command line indicates that it is an it is a single line command statement where we are able to state our instruction for our own understanding in a single line. So the structure involves the preprocessor directive, global variable declaration, then main function where the program begins, and local variable declaration, then variable definition or declaration and computation, then finally displaying the result and closing the main function. So the main function is open and closed by the curly braces. Okay, so this is the basic structure of the C program. Okay, then we will little move ahead of the preprocessor directives in detail. That is the first thing to be checked by the compiler is the preprocessor directives. It always begins with a hash. It tells the compiler about specific options that needs to be aware of during compilation, right? So this is what the instruction, prior instruction given to the compiler, what it is going to do as part of the program execution or compilation. Then there are few compiler directives, but only two of them we are going to discuss here. So one is hash include, another one is hash define. So hash include, as the name indicates, that it is a preprocessor directive to include the header file stdio.h. That means standard input of input header file is included here, which consists of various library functions related for reading input as well as writing the output. The another preprocessor directive is hash defined. So like our constant, we are able to define some fixed value for any particular variable. So wherever that variable occurs, the value what we have defined will be replaced. Okay, so these are the very simple as well as the very important preprocessor directives. Likewise, we are having many other preprocessor directives also. Okay, see, let us look into this example. Here we are defining a variable pi with the values as 3.141592654, right? So this is the value of the variable pi. Look at this example. Here inside the main function, we are having perimeter equal to 2 star pi into radius. So here we have defined pi as 3.141592654, right? So here wherever the variable pi is involved, it is replaced by the value as defined in this as defined preprocessor directive. Okay, so next one is the area. So here we are calculating the area again by placing the value of pi here. So instead of giving the numerical value straight away, we are in a simplified manner. We are denoting the same value with the variable pi. Okay, so come to the second example. Here we are calculating the perimeter and area with the same pi value. So instead of variable, we are giving the value directly. So which is while seeing these two examples, we are able to understand that which is most readable format. Okay, right? So the second, comparing to the second format, second example, the first one is the most readable format, so it is very convenient for us to use. So in such situation like this, we will be using the preprocessor directive called hash define for defining the values. Okay, so a variable can be declared. So we have seen in this what's the structure of the C program as global variable as well as the local variable, right? So global variable means the variable declared outside the main function. Local variable means the variable declared inside the main function. So the global variable as well as the local variable can be used inside the program according to the need. A globally declared variable can be accessed from all parts of the program, and a locally declared variable can only be accessed from inside the function in which the variable is declared. Okay, so this is what the global variable declaration as well as the local variable declaration. So another one is statements, a specification of an action to be taken by the computer as the program executes is denoted as the statements. In our previous example, there are two lines following variable declaration and variable declaration. Okay, that terminates with the semicolon. Global variable means equal to local variable plus some value. Another one is printer total sum is equal to percentage d and denoting it with the global underscore var. Okay, so these two statements involves both the global variable as well as the local variable. Here, each and every line is called as the statements. Okay, the next one is comments. So comment we have seen in that example also as single line comments as well as the multi-line comments. Single line comments starts with two forward slashes and the end of the line is six. So if any statement placed within this single line comment, then it will not be considered for execution by the compiler. Okay. So here is an example. So this is a command. So this is a command is a command line, single line command line. The compiler will not consider this command line for execution. It will take only the printf statement and prints the result as welcome to C. Okay. Then multi-line commands. Multi-line command starts with a slash star and it will ends with a star slash. Any text between slash star and the star slash will be ignored by the compiler. Okay. Then where we are able to state more of lines for our clear understanding. Okay, that's what we are using. That's where we are able to use the multi-line commands. Okay, next we are going to look at the data types. So what is data type basically? data type specify the type of data, what type of data we are going to manipulate in our program, and what is the size and range of the values are denoted by this data type. So data type in C refers to an extensive system used for declaring variable for function of different types. The types of variable determines how much space it occupies in storage and how the bit pattern stored in interpreted. Okay, so this is all about the data type. So the data type is used to identify the type of variable, identify the type of return value, and identify the type of parameters. Okay, there are three major classification in data types of C. So one is primary data type, user-defined data type. Third one is the derived data type. The primary data type involves character, float, int, void. User-defined data types are enum, type def. Derived data types includes pointers, arrays, structures, and union. So character data type includes signed character, unsigned character, and float includes float, double, long double. Int includes int, long int, unsigned long int, long int, unsigned long int, sorted, unsigned sorted. So the elaborate discussion about these data types will be in the theory classes. Okay, just for understanding and also for manipulation, we just come to see this size of each data type and its range. For character, in terms of our 32-bit central processing unit, its size is 1 byte. Similarly, for 64-bit CPU, its size is 1 byte. Similarly, for short, 2 bytes, integer 4 bytes, long 4 bytes, long or double long is denoted as 8 bytes, float is 4 bytes, double is 8 bytes. Okay. Similarly, according to the size, the range of the data also getting varied. Okay, this is what denoted in this table. Okay, so depends on our need to use data type. Okay, then we are coming into the discussion about variables. So we have you might already heard about variable, the term variable. So obviously it is a value which varies continuously. Okay, so basically the variables are containers for storing data values like numbers and characters. So how we are able to create a variable means with the syntax like data type, it is denoted as type, variable name, and value. So we have variable declaration as well as the variable definition. So variable declaration means just declaring a variable with a data type and variable name ended by semicolon. Variable definition means assigning some values to the variables too. So here int with name, then assigning some values equal to 15 as such. So this is what the idea about variables. So once again, repeat, variables are the containers for storing data values like numbers and characters. We can create a variable using the syntax like data type, variable name, and value. So here it is denoted as and denoted with the example as int minum equal to 15. So here int represents the data type, minum is the variable name, then 15 is the value what we are assigning here. Okay, so this is about the variables. Okay, then functions. So let us get into the basic idea of the function. So C program consists of one or more functions which contain a group of statements performs a specific task. Okay, in C program, the functions are the group of or collection of statements which perform its own individual tasks specifically. Okay, C program must at least have one important function, that is the main function. So we can create our own function or use the function that has been created in library. In which case we have to include the respective data files. That is, for example, here we are including the standard input.h header file for including for using the library functions related to various input-output operations. Okay, so here we will learn about three important functions. One is printf, scanf, getchar, as well as putchar function. Okay. In addition with these functions, we will be learning about the format specifier and escape sequences. Okay. Then printf function, as the name indicates that it is for printing something. That means printing the result on the screen. Okay. General format of this printf function is printf, then control string within the quotes you are supposed to specify the control string, or it is otherwise called as the format specifier, then variables. Okay, this is the syntax. Control string is a combination text, format specifier, and escape sequences. Look into this example, print I am printing as thank you. It is a simple statement, so it will print as it is. In other way, that we are in need of using control string, which includes what combination of text, that is total sum is text, and format specifier percentage d is the format specifier, slash f is the escape sequence, comma variable name. So here, total sum is the text, and the percentage d is the format specifier, slash n is an escape sequence. So format specifier specify the format of the data that particular variable is going to, particular variable is having, and what we are going to get as an output. Similarly, escape sequences, it is helpful for what's that, decorating the output, especially if you want to leave one space between one output to another output, means we will be using slash t, or if you want to print an output in a new lines, means that we will be using the escape sequences slash n. Okay, so this is for about the basic idea of printf statement. It is for displaying the result. We will be denoting it with the general format as printf of control string, comma variables. Okay, format specifier we are learning used together with the printf function to tell the compiler what type of data the variable is storing. So it is basically a placeholder for the variable value. So format specifier always starts with the percentage symbol. Okay, so here in this example, I am having a variable called mynum. It is assigned as 15, and by printing the value, for printing that particular value, I need to use a format specifier as percentage d, since it is an integer number, and variable name. This is the syntax. This is the format we are supposed to follow to display or to print any values using the printf function. Okay, so these are the format specifier. So here we almost we will be using percentage d for denoting the integer data type. Okay. Sorry, and the percentage u. This is also for denoting the decimal as well as for denoting the address. Okay, it is an unsigned decimal integer, and the percentage is an integer, sorry, format specifier which includes a decimal point. So we call it as a floating data type, right? We call such a data or called as the float data. So we are able to see this example 76.000. After some decimal point, we are able to see some fraction. What's that? Numbers also after decimal point. So in such cases, we will be using the format specifier as percentage f. Okay. Similarly, for character, we can use percentage c or percentage x, and for string, we can represent it with percentage s. String will be denoted either by double quotes or it may be of single quotes. Okay. This is about the format specifier. So likewise, we are having escape sequence too. Okay. So escape sequences are here listed as slash is for giving getting beep sound, slash b it is for backspace, slash f it is for form feed, slash n it is new line, slash or we are having slash t also we are having, it is a tab space. Okay. So likewise we are having various other escape sequences also. Especially we will be using slash t as well as slash n. Okay. Then scanf statement, reading data from the standard input device can be done with the help of scanf statement. So here scanf, the control stick can be of double quotes, within the double quotes, comma variable name, same as that of the previous statement. But here the one important difference is the ampersand symbol, that is an address operator. Okay, it is an ampersand symbol. So the general format is the same as the printf statement, except it poses the address of the variable, that is denoted by ampersand instead of variable itself to the second function argument. Look into this example. We have declared a variable called the age. We are asking the user to enter the age, and we are reading the input using the scanf statement by scanf percentage d comma ampersand age. Okay, so this example will clearly tells you how we are able to read an input through scanf statement. Okay, the next one is getChar and putChar function. GetChar is used to read character from standard input. Putchar is used to write the character on standard output. So, like if you want to read any single character, we can use the getChar function. In order to display that particular character, we can use the putchar function. So this is also comes with the category of data reading as well as the displaying data. Okay, that is input output statements. So from this content, you are all able to understand the basics of C program structures and scanf statement, printf statements, data types you have studied, format specifier, escape sequences, and how to declare a variables, right? So I hope all of you might much more clear about these basics of C programming. Now we get into uh, experiment. Okay, so in this experiment, we will be learning about the exchanging of two variables, exchanging of values stored in two variables with and without using the third variable. Okay, with the first experiment. So the title of this particular experiment is statements and expression. We learned about statement and expression is nothing but it is a collection of or it is a combination of operators and operands. Okay, so this is a fundamental concept you might come across right more school pre-KG to our college days. We have experienced many kind of expressions, right? So here in our second experiment, we are learning about how to exchange value to variables. Okay, I hope all of you are cleared about what is variable and how to declare a variable, how the values are getting stored in a variable very elaborately, right? So here the objective of this program is to exchange the values stored in two variables with and without using the third variable. Okay, so let us slowly get into the algorithm of the exchange of two values using third variable. So this is an algorithm. So as usual, all the algorithm begins with the statement as start the program. Then the next statement after starting would be always the variable declaration. So since we are going to exchange values of two variables, we are in need of one temporary variable. So we are in need of totally three variables. Then assign, we are getting into the computation part. So the computation here is the first variable value should be passed to the temporary variable and now the first variable is empty, then the value of the first variable should be combined is empty, then the value of the first variable is replaced by the value of the second variable. That means first variable is empty, then the second variable is assigned to the first variable. Then once after this assignment, the first variable gets the value of the second variable. Then the second variable is free now. Then so the value stored in the temporary variable is assigned to the second variable. So now, as a result of this swapping process, first variable received the value of the second variable, and the second variable received the value of the first variable. Okay, so this is the way we are able to swap the variables value. Okay, so look at this code as usual. As per the general structure of the C programming, we are including the header files with the help of preprocessor directive called a hash include, and we are defining the main function. Its return type is int. That means the function will return some integer value. Then void indicates that we are not passing any values to the main function. Then we are getting inside the main function. The first component is the variable declaration, where we are declaring the variables. So as per the algorithm, we are declaring three variables such as A, B, and temp. Okay. So first we are reading the values of two variables A and B using the scanf statement. Okay, so we studied that the scanf statement always begins with the scanf, and within double quotes we must specify the control string, and we have to read the variables value with the help of address operator by prefixing with the address of those two variables. So that is what denoted in this example. Okay. Then swapping logic. So how we are able to swap here? We are assigning the value of the a variable a to temp. Now a gets free. Then we are assigning the value of b to a. Now b gets free. So now the value stored in the temporary variable is assigned to b. So as an outcome of this particular swapping process, we are able to see the or get the result as a swapped values, right? So initially in this example, I am entering A as 33 and B as 44. After swapping, A gets 44 and B gets 33. Okay, so this is what the logic of swapping of two values by using the third variable. So another experiment here is exchanging values of two variables without using third variable. Okay, so here obviously instead of three variables, we are using only the two variable. One is source variable, another one is destination axis. Like that we can have. So here x and y are the two variables we have taken. So x this can be swapped by manipulating x equal to x plus y, then y equal to x minus y, then x equal to x minus y. Okay, so by this particular computation, we are able to achieve the swapping of two values. So in this program, as usual, header file is included. We have a main function. Inside the main function, we have local variable declaration. Two variables defined here, x is x and y. X is assigned as 10 and y is assigned as 20. Then before swapping, those two values are printed out. Then this is the logic for swapping of two values. Then after swapping, again the value of both x and y is printed out. So after swapping in the printf statement, we are able to see the control string here. So control string here involves the what's that? It involves the control string involves the format specifier, escape sequences, as well as some text also. Okay, this should be the combination, or if needed, we can include these two things. Otherwise, we can just print with the format specifier and variable name. So the return zero indicates that this function is not going to return any more values or any computed values, just it is going to return zero to the function. Since it is denoted as int main, its return type is denoted as int main, the return zero is an important statement here. The next, if the output of this particular program also received as x equal to 20 and y equal to 10 as a swap value. Okay, then we are going to the second program of the second subdivision of the second exercise. So distance between 2 points. So here we are going to write a C program to find the distance between 2 points. So the objective is to calculating the distance between 2 points. So as per our previous study, we are all supposed to read the points, that means two coordinates for which we are going to identify the or calculate the distance. Okay, the distance between 2 points using the formula is SQRT of x2 minus x1 whole square plus y2 minus y1 whole square. That's whole square is denoted here as x2 minus x1 into x2 minus x1, y2 minus y1 into y2 minus y1 as like this. Okay, so this is the formula for calculating the distance between 2 points. So this algorithm can be implemented as a program. As such, we are including standard input output.h header file and math header file. So why we are using the math header file here is we are using a function called SQRT. So SQRT is a predefined library function. This particular function is incorporated in a header file called math. Okay, so in order to invoke this particular function, we are in need of including this particular math.h header file. Okay, so as usual, we are declaring the variables. So here the data type of the variable is float. Then variables are x1, y1, x2, y2 to represent the two coordinates, and we need another one variable called distance in order to store the result of the computation. Okay, so distance between between two variables can be calculated by applying this formula and can be displayed with the help of printf statement. Okay, so here the distance between this particular point to f and point to f, first point to f, comma point to f format specifier indicates that it is an x coordinate. Similarly, second format specifier indicates it is a, what's that? It is an it is for second coordinate. Okay, so likewise the first coordinate as well as the second coordinate distance are calculated and displayed as by the formula what we have calculated with the variable name called distance. Okay, so here point f represents that after decimal point we are going to get two digits as an output. Okay, then after, while we are executing this particular code, we are able to see the result as the distance between 43.00 and 45.00. This point to f is f results, point to f results dot 00. After decimal point we have two digits. Similarly, another coordinate is 66.00 and 78.00. The distance between these two coordinates are calculated and it is displayed as 40.22. Okay, so I hope you are able to clearly understand the usage of header files, main function, defining the main function, way how to define the main function, how to declare a local as well as the global variable based on the need, input for reading the input using scanf function, and displaying the result using the output function, and how to evaluate the expression, how the mathematical functions can be invoked using the header file. All we have studied in this experiment. Okay, I hope you might be having clear picture about these two experiments. The third one is arithmetic expressions. Okay, so this is very simple example for understanding the concept of arithmetic expression. So objective of this program is to display the result of arithmetic expression. As usual, we are starting the program reading two numbers for manipulating using various arithmetic operators. Okay, so those two numbers can be of two variables will be manipulated and their result should be stored in some other new variables. So accordingly, we are supposed to declare a variable and we need to perform the arithmetic operations such as addition, subtraction, multiplication, division, modulo division, pre-increment, post-increment, pre-decrement, and post-decrements. Okay, these are the operations we are going to do in this exercise. Okay, so as usual, we are reading the values for the variables and we are doing the computation and displaying the result. These are the three simple steps we are supposed to follow here. So getting program here, first we are including the file. So the header file here is sti.h, that is standard input output .h header file. Then you are defining the function where it represents the written type of the main function. Inside the main function, we are having the variable declaration. Here, declaring variable as in a local. So it is denoted here as local variable declaration. Okay. So what are the variables we are declaring here? A, B, and another. The third variable is the what's the third variable is the result or the variable which stores the output of the computation. Okay. Then the next one we are reading the input for A and B, right? So we are able to read the input with the help of what scanf function. Okay, so this is the representation of that particular scanf statement. Scanf percentage d slash n percentage d comma ampersand a and comma ampersand b. We are reading the values of two variables. Then we are getting into the operation or the computation part. So if it is an arithmetic expressions with addition means, then we are simply use an operator called plus. Okay, this is for simple addition. We are storing the result in the variable called result. Then just we are printing. Next, we are doing the subtraction. It is denoted by A minus B. Then the third one is the multiplication, A star B. Fourth one is division, A slash B. And we will be doing the modulo division also. Okay, that is denoted by modulo division symbol. And finally, we are able to print the results. Either on that current location itself, we are able to see the output, or otherwise by summarily having different variables for each and every computation, we can display the results individually. Okay. Similarly, we are exploring with the increment operators. So here we have two types of increment operator. One is pre-increment as well as the post-increment operation. Okay. So pre-increment means the operator, increment operator will be a prefix of any operator. Then post-increments means the increment operator would be the suffix component of the any increment operation. Similarly, we are having pre-decrement as well as the post decrement also. Okay, so this is the post decrement, this is the pre decrement. Okay, so before pre-decrement or pre-increment, what will happens in this nature of operator is pre-decrement means so initially the value will be assigned and then incremented. That is post-decrement. But pre-decrement means the value is getting incremented or decremented and then it is assigned to the respective output variable. So here this is what the case means. If the variable result will get the result of decremented A. Okay, so it will be assigned initial. It will be decremented and then it will be assigned. Okay, this is what the pre-decrement. You are all while experiencing, exploring this code, you are all able to understand the difference between pre-increment as well as the post-increment, pre-decrement as well as the post-decrement. So in this example, we studied about the arithmetic expressions using various arithmetic operators, which are the operators we already know very well in all kind of mathematical computations. Just we are implementing those operations in the form of C programming or C code. Okay, so that's all about the fundamentals of these three exercises of experiment number 2. Okay, I hope all of you might clear about the concept of the experiment 2 statements and expressions. Okay, thank you.